So here we just continue and to summarize what the kind of register we have learned here. So basically we use the argument register. This is the kind of first time we talk about this register. So although we call it a general purpose register, but conventionally those four registers only used to store the argument prepared by the main procedure. And we also learned the return value register V0, V1. It has the corresponding index 2 and 3. Okay, so and this is, although again this is a general purpose register, but here the main purpose conventionally is used to return the return value from the callee. And we also deal with the T0 and T2, T9, S0 to S7, which refer to temporary register and saved register. Those ones, like we said before, is just to contain some variable in order to implement operation. Before I mentioned, and generally you can just treat them similar, and we will talk about different later. And now is the time we talk about why it is different. Why we're using temporary register and using saved register. What's the difference between them? The difference here is during the procedure call, the temporary register potentially can be overwritten by callee. So basically, if certain temporary register used by the main procedure and already has the meaningful value inside, but when you call the callee, if callee using the same register, it potentially can override that value. So after you call the return and the link, and return that control back to the caller, that value in this temporary register could potentially be changed. However, the saved register not allowed to be touched by the callee. So in other words, as long as so basically the callee want to implement something using some general purpose register to contain some parameter, and theoretically speaking, they are allowed using this kind of saved register. So in other words, you will, as long as your main procedure using those saved register, you don't vary that the value inside that can be changed or overwritten by callee. That is the main difference. Say one more time, temporary register in or used by the caller potentially can be overwritten by the callee if they implement procedure call. And the value inside of the saved register, which potentially be used by the caller, will not be overwritten through the procedure call. And we also will talk about the other system level register, for example, global register, global pointer, stack pointer, frame pointer, and this is we will talk very soon. And next one, we already learned this global register called the return address register, right? We mentioned in the jump on the link, return address will store the location where you want to jump back to after you finish your sub procedure. And similar to the saved register, this four system level register will not be allowed to be touched by callee. So in other words, the you will not vary, those values will be overwritten if you implement procedure call. So now the question will be here, okay? So you're not allowed to touch by callees. That's why I say theoretical speaking. Why I say theoretical speaking? Because it's not practical. Why it's not practical? Because you only have totally 32 general purpose register. And some register already have the special usage. So you have very limited register potential can use for the general operation. So if you not allow the callee to touch those saved register, so they only have very limited variable can play with. So is there any way we potentially still practically touch those register, cannot use those saved register by the callee, but also guaranteed this value will be not changed through procedure call? Let me repeat my question. So practically speaking, callee might need to using saved register, for example, to implement the operation in order to guarantee the available variable, the number of available variable is sufficient for the operation. However, I want to ask whether there is some mechanism we potentially comply so that although the callee might touch those general purpose register S0 to S3, S7, but they will not for sure overwrite the value on that. So I want you to pause here to think about this question. Is there some mechanism you can think? Basically, those saved register can be touched by callee, but will not overwritten for sure by callee. So you can think about it and then continue. So here I give you another just example, okay? So basically you potentially might want to borrow a car from me, okay? So and then I will say you are not allowed to touch anything, any items in the car, okay? But you originally agree, but the problem is maybe you need to use a car to carry some stuff with you. But the point is, you're not allowed, I said, theoretically speaking, not allowed to touch those items. So you have two ways, right? One way is you really need a car, need enough space to carry some stuff, and your friend not allowed you to touch the inside items. So you potentially will decide not to borrow the car from this friend. But there's another way is you can first store those items originally in the car to a very safe storage place, for example, your home, and then you using car to carry the item you want to use to carry to. And then after you carry that, you restore the original stuff to the car. Basically, those items, although you touch that, but it's equivalent to not touching because you not cause any change of the item. All you do is you first store that stuff into the other place, and then after you use the car, you will store back to the car. So similarly to here, so basically theoretically, I said you're not allowed to using those safety register, but practically it's not really sufficient. So what you do is you can store the item, the value inside those kind of safety register into someplace else. And then you're using those general purpose safety register to do whatever operation you want to implement. After you implement, you store the original value which you already store somewhere else back to those safety register. By doing so, basically you does not change or for sure does not change any value original in the safety register through the procedure call. Let me say one more time. In order to still using those safety register, but not guarantee not overwritten those kind of register value. What you do is before this callee want to use in the safety register, the first thing they do is store the original value in the safety register to somewhere else. And then they use this register for whatever purpose want to use. After that, before return the control back to the caller, the callee will store the original value from the somewhere else to back to those safety register, and then call the jump and return to return the control. I hope this is clear. So that's why here I say you have to save and store, restore, and here similarly to the global or system-wise register and global pointer and stack pointer, frame pointer, and return address. You also need to do save and return. Okay, so here is give an overview about all the registers we have learned until now. We have learned register 0, right? Only hardwire to low voltage, basically always have the constant 0, and a temporary register, and the assembler temporary register. I still remember what is assembler temporary register, so you can pause here to think about it. So the assembler temporary register is a preserved or reserved use for the assembler to translate from the pseudo instruction to the official instruction. You remember before we said branch if greater than, right? And or the branch if greater equal to, and those things is can translated by using the branch if equal and the set on less than, or branch if not equal set on less than, right? In order to translate that, you need to using the sampler. In other words, you So you do not have to write this way, right? You can write this way because the assembler understands your that instruction, but that instruction does not called official instruction. You cannot find them in your instruction set architecture, but that's why we call it pseudo instruction. But assembler has the functionality to convert pseudo instruction to the representation by using the official instruction. Through this procedure, a sampler and temporary register really play the role, right? So they can help to reserve some to contain some intermediate value without have the value conflict and on the general purpose register. And then today in the procedure call, we learned this return value V0 and V1 argument register A0 and A3 to A3. And we also learned the T0, T7, and T8 to T9, which are temporary register. Potential can be overwritten in the procedure call. And S0 to S7 is a safety register, cannot be overwritten by the procedure call. Also has a system register, global pointer, stack pointer, frame pointer, and a return address. And here until now we only learned the first one is the return address. Basically help to contain the location which you want to jump back to when you finish your callee, right? Okay. So